Hello. Thank
Hello.
you. Thank you for being here for the Pegnet status meeting. We're gonna uh, we're gonna do a little bit of a tour of the current state of the Pegnet in Accumulate, and then we'll go over um, the status of Pegnet, what development's being done, and then I'll answer any questions. And I appreciate Louise showing up for to support the stand up today. Say hi, Louise.
Hi, everyone.
Okay, so yeah, so just for grins, because a lot of people haven't seen this, let's just do a quick review of what the PegNet looks like today, where what's running, and what's running is we had a bunch of PegNet assets that were issued on the Factum implementation of the PegNet. And when Accumulate activated, the software that interpreted the blockchain uh, no longer functioned. And the way PegNet worked, you had to use the PegNet daemon to see the balances on Factum addresses. And when we activated Accumulate, we took all the Factum addresses and we ported them into Accumulate as something that we call um, light accounts. And a light account is simply a URL of the Factum address in a slightly different format, and it can hold the original factoid tokens, which got converted into Accumulate when Accumulate activated, and those addresses hold Pegnet assets, but that wasn't literally in Factum. That was literally in the Pegnet software. So what we did when we activated the Pegnet is we created a Pegnet identity, accumulate identity. We call it an accumulate digital identity, an ADI. So the Pegnet has an ADI, and we're just going to go pull up the Accumulate Explorer and look at how the Pegnet is implemented inside of the Pegnet ADI and how those assets are distributed to everybody that had um, pegged assets. Now, the big advantage of Accumulate is the protocol handles the tokens. And so now you don't need a special Pegnet wallet. You can use an Accumulate wallet to hold your tokens and to send tokens and to receive tokens. And you can use the Accumulate Explorer to look at your balances. And so we're kind of going to go over the state of the art here. And we'll point out some things that we'll want to upgrade later. So let's look at the Accumulate Explorer. So let me bring it up on my screen. So this is the Accumulate Explorer. Let me make it a little bigger so it fits. And when you just go to explore.accumulatenetwork.io, and you can search for it for just Accumulate Space Explorer, and the first link will be the um, Explorer here. You'll first you'll see that it looks a lot like a browser. There's a search term and then some data that's displayed. Um, so we can go to the Pegnet ADI by typing in the search bar pegnet.acme, and that will bring us to the Pegnet ADI. And if we look at the Pegnet ADI and we look in the directory, we see that it has pegnet.acme assets, and it has a pegnet.acme book. This is the security for the Pegnet ADI, which that's under development, so there's not much to see there. But the Pegnet assets, if we click that, we can see all of the issuance accounts for all of the assets. Now, we have to convert when we did the conversion, we converted factoids directly into the Pegnet. And so we're going to have a conversion process so you can exchange your factoids to Acme, and but like we did in the Acme protocol. But that's ongoing. But here is the ADA issuance account. If I go back, you can see Algo and Atom and uh, basic and BAT tokens, BNB tokens, so forth. In fact, if I expand this page, all the 60 some odd assets that we've issued, you can see here. Now, one of the big assets that we have issued is our PUSD, which just is shown as USD here. So if I look at the pegged USD, I can see the issuance, the tokens issued. And if I go to one of those, these are the synthetic transactions that actually are the deposits into various accounts. And if I scroll past all that, I can see the issuance to each Factom address. So if you had some Factom address in Factom for the Pegnet, if you type that in the search bar, you'll go to the associated ADI. So let's go to this first one, and you'll see that it has a balance of $24.39 roughly, because that's what it had in Factom, and that token is issued here in Accumulate. And you can today in an Accumulate wallet, you can send the Pegnet asset, the PUSD, to somebody else, or into another account, or receive Pegnet assets. So they're all liquid; they can all move. It's just that we haven't gotten the architecture built that will allow the conversions and trading and arbitrage that maintains the value of PUSD at $1 in the market. Now, note that when I look here in this account, I can see that the asset that I'm holding is Pegnet.acme assets USD. So you have no problem seeing what asset you have. Now, if I go up to just the light identity, I can look at the assets this light identity holds. And it actually holds quite a lot of assets, a little of this and that. So let's look at PEG. PEG is also an asset that a lot of people are holding. And I can see that that same light account holds 293.57 PEG. So you can basically look at all your assets, and you could move them around if you wanted to. Any questions?
Not for now.
Not for now. Okay.
Yes.
All right. So let's talk about where we are in development with the Pegnet. We I have written the code that does the mining, and the miners pick up the well. First off, we're developing mining for Accumulate first, and Accumulate will, that mining software will have everything except the Oracle record construction. Once we add Oracle record construction to Accumulate mining, then we can reuse all this code. So it's kind of incredibly important that we get mining on Accumulate working. Now, Accumulate is largely proof of stake, but there is a concept called retrospective mining. And what you do in retrospective mining is you take the hash of the summary of the blockchain, and you mine that hash and you write that proof of work into the blockchain within some period of time, let's say 10 minutes. And then you pick up uh, uh, the next summary that's available uh, to mine, and you mine that one. And you might not mine the hash of every block. You may, in our case, you wouldn't come close because Accumulate's creating blocks about once a second. We'll probably mine for 10 minutes. Um, but you you can mine what you want, keep those solutions in a chain, and then when people are creating cryptographic proofs, they can create cryptographic proofs that go to mining blocks that have hash power recorded against them. And that hash power basically proves that a lot of people are witnessing the top of the chain at the time that hash was built. And so that kind of cryptographic proof is very easy to evaluate. Now, yeah, go ahead, Luis.
Yes, I was wondering what is the repartition between proof of work and proof of stake with Accumulate? Because you told us that um, both are used, right? But
Right.
if it was possible to give a percentage for both of them, what would this, what would it be?
Okay. Well, very few chains do both. We're going to be one of them that does. The proof of work, famously, is what Bitcoin uses, and Litecoin and Monero and some other blockchains. Proof of stake allows you to pre-select the parties that are building blocks, and they're secured by putting basically being bonded by some tokens that they put up, and if they misbehave, they can lose those tokens. So that's kind of a way of securing the blockchain, but it allows you to gain efficiencies because you're not competing with each other with your proof of work to build blocks. You are using some more scheduled algorithm to build blocks. And so blocks that use proof of stake are very efficiently built, but the problem is they're not very easy to prove the historical record. And so this is the analogy, one analogy to consider. If we were talking about elected leadership in a country, the valid elected officials are the people that won the last few elections. You don't have to go all the way through a country's history to figure out who is the um, rightful leaders of a country. You just have to go to the previous election and see who got elected. Uh, if you were a strict monarchy where by law you had to have royal blood, and you had certain restrictions about how that royal blood allows the next person to lead and the next person and so forth, then if I just came in as a third party into such a country and I wanted to know if the leader that I think is the leader really is the leader, I have to prove his ancestry. So if Saint John the First was the guy who established the country in the royal line, and he lived 2,000 years ago, I would in some sort of kind of the way we have to do things in crypto, I would have to go back to St. John the First and prove the bloodline all the way up to the present, maybe 2,000 years or something. And that would be really, really hard. So proof of work, but when it came to leader transitions, it would be really, really straightforward how that worked because he has a set of kids and you got to pick one of them. It's not very hard. When you have elections and anybody could run, well, you have to do this whole nationwide thing and everybody has to sort out who got how many votes, eventually you figure out who's the leader. So elections are messy and but easy to validate in the present. A bloodline is easy to evaluate who needs to do the work, but a little harder to prove to a third party. Okay, does that make sense?
Yes.
Okay.
Thank you. Uh, n- yes. Maybe I heard about the all the DIO stuff. I mean, yeah,
The
you.
Dow.
Yes.
Oh, so um, so this is kind of a question of what kind of stable coins exist, and there's really um, three types of stable coins. There are coins that are asset based, like for instance, Tether and USDC are ostensibly there are dollars that are packed away for every one of those USD coins or Tether coins, and and at least theoretically, if you turn your tokens in, they can give you dollars for your tokens, and that's how you create a USD backed stablecoin. Now there are crypto backed stable coins where you have some sort of mechanism to create liquidity in the crypto space that backs your token by value. But one of the problems with that is that crypto values go way up and way down. And so that makes it hard to maintain a base of value that will back your stable coin. The third type is an algorithmic stable coin like the MakerDAO, and they have smart contracts and create and pay out interest and have multiple tokens in order to create incentives to keep the DAO stable. And all three mechanisms work. The regulators are largely focused on the asset-backed stable coins. Pegnet is a maybe a fourth type because the Pegnet creates incentives in the protocol and the market. It doesn't have any mechanism that explicitly maintains stability. It's just that by design, there are ways to trade the Pegnet in the market where you can make profit if the pegged asset is low, or make profit if the asset is high. So there are ways you can make money and bring down the price to $1, and there's ways you can make money by bringing the asset up to $1. And we'll do a bigger presentation on that next time. Let's not do it now.
Okay. Thank you.
All right. So let's talk about the PegnetStatus. So um, I think, as I was saying, the the mining code is largely complete. It's being written for Accumulate, and we'll be able to reuse it for the Pegnet. One of the things that I need to code into it is some simplistic algorithms for deciding how you make submissions to the potential solution, so that you optimize the number of points you gain. We'll talk about points in just a second, because what we want to do is create a system where we don't need mining pools in the immediate term. That mining pools can develop later. And how we're doing that is we issue points to 300 up to 300 submissions that are made during the block, and um, the miners gain points for how many entries they have and how high in the sorted by difficulty 300 um, submissions list they are. They get more points. So you get a little more points if you have more hash power, but a few points if you make the list. And those points continue um, pretty much forever. And as you gain points, you eventually have enough points to earn rewards. You earn rewards, and then your point balance is zeroed. Now, if I have a whole lot of hash power, I come in and I hash and I end up winning blocks. But every time I win a block with my hash power, those points get cleared out and I'm back to zero. That way, the the tortoise, you know, steady as you go, earns points and wins. But so does the hare. The hare wins, but then the hare's reset and has to start the race all over again. Eventually, the tortoise is going to win no matter what. Um, so far, what's implemented is the point system. Point system's implemented. The payout calculations in the testing that's been implemented. The difficulty adjustment, because we're going to have a target difficulty that we raise and lower to keep the blocks roughly 10 minutes long, and that algorithm is implemented in testing. I'm having a few issues with it. I have to look at that, but I think it's mostly done. Then we need to the validators need to provide the hash to be mined. Once we end a block, a new hash has to be provided, and that's for mining on accumulate. When we get into the Pegnet, a Oracle price record has to be created, and it has to be provided to the users to mine. Um, so that's the leader, the validator leader that does all that work. When you want to mine, you'll just download the code, do a little bit of configuration setup, but nothing complex, and mine away, and you'll be earning points and earning tokens. The things that we haven't started done yet is we have not uh, implemented multiple validators, because we're supposed to have multiple validators and the leader swaps out. So I haven't written that code. It's not terribly hard. We haven't done an integration to accumulate so that we're actually running against accumulate. Right now, I'm kind of running against an image of accumulate. And we need code to reject bad leader records and slash leaders who fail to perform. And that's pretty much it. The accumulate integration will replace the simulation, and the code will be mostly operational.
Okay.
So once this is done, the next thing to implement is the actual functions, like the conversions of one asset to another inside of accumulate. Um, Implement the code to weight um, the spread between the values in the market. We use an artificial spread to keep people from gaming the Pegnet. One of the reasons we're going to use difficulty is to prevent some gaming of the Pegnet, because when the block ends, it will be difficult to determine, and that'll mess up a lot of strategies people have used in the past to try to attack the Pegnet. And then we'll be good to go. We are primarily, I have my priorities. I'm raising resources, so I'm trying to get resources and using what resources I have to move forward. Then we need to get both accumulate and Pegnet assets back on exchanges. Part of that will be in the third priority is building infrastructure like a DEX, a distributed exchange that runs on accumulate, so that we actually have an open market in the accumulate protocol that can trade Bitcoin, Ethereum, and other tokens against token assets that exist in accumulate itself. And so getting that built is kind of a bit of a priority. And then we're off to the races. We're good to go.